Let's look at an applied context where we can use the sine and cosine functions. Suppose Nick is skiing on a circular ski trail that has a radius of 2.2 kilometers. Nick starts at the 3 o'clock position and travels counterclockwise. Let's assume that Nick sweeps out 1.3 radians. So with any math problem, we should start by drawing a diagram, or at least imagining one. So we'll go ahead and draw one. So Nick is on a circular ski trail, something like this. He starts at the 3 o'clock position, and then he rotates counterclockwise. So he's traveling this way along that circular ski trail. And then he stops after the angle that subtends that arc has a measure of 1.3 radians. So if we imagine an angle whose vertex is at the center of the circular ski trail and whose rays cut off that path that Nick actually travels, then this angle has a measure of 1.3 radians. So if we imagine a vertical and horizontal diameter passing through the circular ski trail, so we'll try to draw these in, then we can use the sine and cosine functions along with that angle measure to talk about that terminal point's location relative to the center of the ski trail. So this is where Nick stops skiing. We can talk about that location using the sine and cosine functions. So as an example, so if we look at Nick's horizontal distance to the right of the center of the ski trail, then that horizontal distance is cosine of 1.3 radius lengths. So cosine of 1.3 tells us that horizontal distance measured in radius lengths, or radii to say for short. And on the other hand, if we wanted to look at his distance above the center of the ski trail, then that distance would be sine of 1.3 radius lengths. So radius length is kind of a cool unit of angle measure, but probably not something you would use to communicate an actual distance in the real world. So instead, you'd probably want to communicate it as a number of kilometers. So recall that the radius of the circular ski trail is 2.2 kilometers long. And so if Nick is cosine of 1.3 radius lengths to the right of the center of the circle, and the length of the radius is 2.2 kilometers, then he will be cosine of 1.3 times the 2.2 kilometers. So 2.2 times the cosine of 1.3 gives us a number of kilometers to the right of the center of the ski trail. And again, that's because this represents a number of radius lengths. Each radius length is 2.2 kilometers long, so you multiply those together and it gives you that distance measured in kilometers. Similarly, Nick is sine of 1.3 radius lengths above the center of the ski trail, but each radius length is 2.2 kilometers long, and so he is 2.2 times sine of 1.3 kilometers above the center of the ski trail.